Thank you for your attention for the whole of this 2.5 days. I started this on Friday afternoon, and it's my job to give the last lecture. It's going to be a very short one. We are running short of time, so I hope you'll bear with me to rush this through. It's going to be a spoken explanation. There's a few words on the slides, and I'm going to talk it through, and hopefully give you a short demo of the warehouse for FUNcube. The warehouse itself is just has been said before, it's just software. This is the usual sort of thing. I'm going to talk through what we wanted, what's out there already, how we designed it, how we test it, how we make it work, and how we integrate it with other systems, again, so and such like, and what we want to get out at the end. So that's the quick overview of what I'm going to talk about. It'll be very rushed because we're short of time. Main requirements, because we want to actually be able to give it to as many people as possible and have them use it worldwide, it had to be web-based. We also made a decision right at the outset it would be open source. It will be open source, that is the guarantee. It's currently running on one of our servers at the moment, but we're more than happy to put it onto one of the Google open source platforms or one of the similar ones. It should have good accessibility. By that I mean it's not going to be a really whizzy website, it's not going to be full of graphics, it's going to give you the raw information that you need, so it's accessible to all users. Accessible on the website as a web application. If my phone's still working, if my battery hasn't gone flat. You probably can't see it from down there, but I'm not going to pass the phone around. But that's the dashboard actually running on a mobile phone as well. I don't think I can actually zoom in if it's... maybe a little bit too small for the camera over there. Okay, it's fine. So we wanted to make it accessible to all sorts of devices. To do that, it became a web application. As part of the database and upload of data, we needed a mechanism for registration of ground stations. You'll see if we get to the demo, there's a registration page. It's a standard sort of thing, username, email address, location, and a couple of other things. What we'll email you back is a registration key. Well, it's a registration key that validates your login the first time, but it's also what we use with the ground station software, with the dashboard software, to actually validate the data that's coming into the warehouse. We don't want the data to be spoofed. We don't want to get rubbish data in, so we validate the data that's coming in. Two types of upload. One will be real-time telemetry. The dashboard that's been generated, you've seen Graham demonstrate yesterday, can upload the data every 5 seconds, or you can do it as a bulk upload. Currently, we're working on the 5-second version. The bulk upload is still to be done. One of the things we decided right at the outset was that the end user, because they've given us the benefit of their ground station, should be able to download their own data. So when they log in, they'll be given the opportunity to give a time span for the data they want, and we'll give them a CSV file that can be loaded into Microsoft Excel. They can do whatever they want with their graphing with it. That's the contract we have with the end users. As well as the end users being able to do their own analysis, the warehouse will also do lots of nice graphing and trending analysis and such like, so we can determine spin, we can determine charge, all the usual things. There are some good exemplars out there already. Our friends at Delphi C3 with the Rascal offering. This you saw yesterday. Sorry, it's out of focus. This is the PC dashboard, which actually will feed the warehouse. And of course, our colleagues in AMSAT North America with the ARISAT dashboard as well. So there's lots of examples. So we have lots of things to base our development on. No point reinventing the wheel. To some extent, it's a software engineering exercise as well. Because we're making it open source, we want to give some good examples of how to do software engineering. My background is big enterprise systems, and we test first. We actually write the test first. It breaks. You fix it. It breaks. Loop again. So it's all done using test-driven development. All the bits of the stack, the database, the application layer, the graphing, and everything is actually done is testable. It's written in Java, my choice, a choice of all the other developers as well. We did it like that so it'll actually run on a Windows platform or a Linux platform or a Mac as well. The intention was that other people can use this warehouse. There is a lot of talk. There's been some discussion this week about whether we can actually share our database with other satellites, other devices. Yes, perfectly possible. We've already started to look at some of the stuff for FUNcube, managing 2 satellites at the same time, but they're ongoing discussions. We're using open source libraries, again, because if we use an open source library, we're mandated to make our own source available to the general public as well. Software engineering point at this point, it's a web service application. So basically it uses everything that HTTP uses. There's no magic there. It uses all the standard protocols. And we're not hiding anything except maybe some of the security for user logins, etc. Integration, it's over the internet. There's no magic networks involved. It's standard HTTP protocols. Multiple sources, I mean, we've got to be able to integrate with all these, hopefully, these hundreds of radio hams around the world that are going to be feeding us data. I think I'm modelling modelling maximum 100 concurrent users feeding the system. I don't have the numbers from Delphi C3, but they had quite a good number of feeds coming in. We said multiple platforms because we have the dashboard feeding us. There may be other mechanisms by which people want to send data to us. So we've made the API, the mechanism by which data gets into the warehouse, as open as possible. Data analysis that's going to come out of it. There is a specification of the satellite's telemetry, the hexadecimal format, what the parameters are, and how the data is mixed up in the frame. That's online as well. But basically, we have real-time data that's sent with every packet. Mixed in with it is high-precision data for the mechanical analysis we're doing off the satellite for the outreach. And we've also got whole orbit data. This is all mixed. This is encoded into the set of 24 frames that come down from the satellite every 2 minutes. So we get a packet every 5 seconds. That's how it's intended to work. That was quick. Trying to catch up on time. So we had a set of requirements set out probably about 2 years ago. They haven't changed a great deal since then. It was well written. We've found a couple of mistakes as we got the satellite live last week. Hey guys, we're going to go at RAL. We're testing the satellite. We're bouncing it about. We're heating it up. We're cooling it down. Hey Dave, can you pick up the data? So first test of the data was, oh my God, I'm not receiving anything. All my tests run fine, and it's a quick look at the data stream coming down, and because we had expected a continuous stream of hexadecimal bytes, I was getting hex pair space, hex pair space. So a quick bit of change of the software, strip all the spaces out, and she worked first time. We received something like 20 packets from the satellite being bounced around and warmed up and cooled. As then said, we've got the exemplars. We're doing all the voltages, currents, temperatures, receive parameters as data. Design. Design's come from my background in software engineering, and we're now, because we've actually we've thrown it out to the general public about 6 weeks ago for the first time, really, on the FUNcube chat room. People are giving me feedback, which is great. Let's get it now before we start going live with it. Predominantly around sort of registration and login and usability, which is great. Testing. As far as software engineering is concerned, the code base has got something like 95% code coverage in actual static testing and dynamic runtime as well. Implementation, Java, as I've said, works really well. Nice and simple stack. Everything's open and available. Integration, we've already proved we can actually get satellite data from the dashboard downline. Data analysis is one of the next steps. We've actually done a bit of a kludge to get data out of the database, push it into CSV, show it in an Excel spreadsheet. That works as well. Not sure if I can ask the BATC guys, can I change the VGA to my other laptop? Okay. Oh, before we do this, I'll try and do on here. And you can. There's no reason why anybody can't see this. You can all go to it. It's API.FUNcube. Can't spell. I hope. Thank you. What do I do that for? I'm so used to writing my own. I'm so used to writing code for my own company. Yes. Thank you. It's not quite. Should fit the screen, really. Oops. This is the warehouse in all its glory. This is the front page that everybody sees. These are the sequence numbers. This is real data off the satellite. I think we're running about 2028 on the sequence number now. Ignore the values; they're not scaled. It's the raw hex data coming off the stream. As Walter said yesterday, they were doing the calibration of the thermocouples and voltage readings, etc. So they've got to be factored in. So this is the front page. You can see lots of sort of basic data. As you can see, it looks very similar to what Rascal does with its basic information. We have, whoops, a daisy. So we have a dashboard. We have the usual login and remember me. But as I said, we have a registration code for the first login, which is the piece of information we use for stopping spoofing of data. And we have a registration page. I welcome you to come and register. The more, the better. I think I've got something like 50 people who registered for just for testing. Again, it's all the standard stuff. We've already had sort of comments about what do you mean by can we have some examples of longitude, or can we have degrees, minutes, seconds instead of decimal? It's all been worthwhile feedback. There you go. Thank you, Graham. Real time. How about that? That's me. Done. Any questions?
Yes, Luke. You have a